Okay, today, what do you guys want to do today? I was thinking that we would want to review the tic-tac-toe assignment, right? Should we do the review to see where we went wrong?
Yeah.
Okay, so let's start. Let me start writing the tic-tac-toe program. Okay, so let's just compare what was requested. So it says to write a program, tic-tac-toe program should behave as shown in the screenshot. So it should start with the board, right? This is the board, and it goes row by row, numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so obviously we need to print this board, right? Because it's printed every time. And like I said in the last class, we can represent this board as a list of list, right? So let's do that. Okay, so let's create a main method. Okay, in here we need some while loop, right? Because we need to print this board, right? And then we will create a function, or we'll call a function called print board. Okay, we need to print that board. So let's define the print board function. Okay, before print board we need the board. Okay, so let's define a variable called board, which is going to be a list of list. Okay, so we need 3 elements in the list, and each of them are going to be list. So if you want to go and visualize, let's try to visualize this thing. So we need a board, right? And then each element is a list, right? Right, so I'm just drawing it like this. So we can visualize that the first element is the column, first column. Second element is the second column, and third element is the third column. Okay, so going this way, okay, these are the columns, and going this way, these are the rows. Okay, so usually in mathematics, usually the columns are x's, called x, okay, and the rows are y's. Okay, or x could be the so in a coordinate system, for example, right, you have the x-axis and you have the y-axis, right? So x is always horizontal and y is vertical. So in here the horizontal is the x and the vertical is the y. So if I say list, sorry, let's say this is our game. Okay, sorry, board. Where's my thing? So board, board. Ah. Okay, so let's say the board is pointing to this list. Okay, so if I say board at some value 0, what would I get? I would get this list, right? That's the first element, right? 0. So and if I say 1, it's going to give me this one, right? And 2 is this one. So this is 0, this is 1, and this is 2. Okay, right? And but I want to represent the board with these numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So if I say so in mathematics, whenever you define a point, right, you always say x comma y. That's what a point is. Okay, so let's say in this case x could be, let's say 2 and y is 2 or something like that, or 3. Okay, so I would say this point as 3 2. Okay, so if we have that convention, what would this point, how would I represent this point? For me, I am representing the x and y this way, right? X going this way and y going this way. Okay, so this one would be, if I access the element 0 0, right, 0 would give me this list, and within that list 0, right, another open bracket, like a square bracket, would give me this element, right? And then if I say 1 0, right, that will give me this guy, right? 1 would give me this list, and within the 0th element within that will be 2, right? So x y, so if I say 0 1 2 2 2, that will give me this one, right? Is everybody clear on that, how we are representing this, right? So having this, then how would I go and write my board? So if I think of this board, so this is my 0th list, which is my column. So every element is basically a column, right? Within the column, I'm going to have the row values. So I would have 1. The next one would not be 2, because I'm defining this list, right? Because this is my 0th element. It has to be 1 4 7, not 1 2 3, because 1 2 and 3 are in a different position, right? So it's not in the same list. This is the first list, this is the second list, and this is the third list, right? So it has to be 1 4 7, not 1 2 3. Did you guys make that mistake? Who made that mistake?
I did 1 2 3, but then I found a way to work around it and did it like that.
Okay.
I did it the 1 4 7.
Yeah, so even with 1 2 3, you can also do it like what you did.
Yeah, because you have to. I did. So when I did my print screen function, I printed y then x. So then it worked.
Okay. So you had this list as 1 2 3 this way. That is also one way of doing it. That is perfectly fine.
And I found it easier to just read through it to make sure I had the numbers in the right spot.
Okay. So the reason why I'm doing it is because in mathematical convention you always say x and y for a point. So and I didn't want to access board at y and then x, because you would have done it that way, right? If you had done it that.
Yeah, I printed the board like that.
Y and x. So if you want x and y, because that's the normal convention when you learn this is called the Cartesian product. So like I'm sure you have learned lines, right? Graphs and lines, and it's always the points starts with x and y.
Yeah.
So that is why I want to keep that convention in my board. In order to access any value, I wanted to give the coordinates in x and y. So for me, x and y's would take 0 to 3, right? X would take values from 0 to 2, and y would take values from 0 to 2, because this is 0, this is 1, and this is 2, right? So that's why we have to do it that way. So 1 4 7 2 5 8 and 3 6 9. Okay, so now we need to define a function to print this board. Okay, so let's define this. Obviously it's going to have to take in the board, right? And how can we print this board? So we need to go in print function. We can only do row by row, right? Because when you print to a console, you can only do row by row. You cannot come back and like there's no way to come back to that line when you print it, like in the console, right? When you print it, you print it one line at a time. You cannot come back, right? So we need to print we need to print the elements in the row 0, column 0, row 0, column 1, row 0, column 2. So we print this line 1, 2, 3, and then 4, 5, 6, and 7, 8, 9, right? So we cannot print like 1, 4, 7, 2, 5, 8, 3, 6, 9, because in the console we cannot do that. We can only print row by row, right? So let's do that. So I would say I need a for loop for sure, right? Because I have to iterate through each row. So I would say for, and what is a row? Row, we said y, right? Row. So let's call this y. Or actually, let's call this row. For row in range 3, okay? Because I have 3 values, and the range is, the last one is exclusive. So range would give me, for this iteration, it will give me 0, 1, 2. Okay, so I have a way to go by row, right? But now I need to collect these values, right? So I need to go again for this row. I need to go 0, 1, 2 for columns, right? Do you see that? So I would need another range then, right? Within that range. So for every row, I need to go for every column in that row. That's what I'm doing. So column in range. Again, I need to go over 3 values, right? 0, 1, 2 for each row, right? So now I have my indexes set up, row and column. So I can simply say print, right? To access the element, I would say board at row and column, okay? Right? I would print. So what would this do? Let's just do that, okay? Since here I have a while true, I don't want to keep printing the board again and again, so I'm just going to temporarily put an input in here, okay? So we just only print that board once, okay? So let's call our main method. Okay, actually I haven't taught you guys this, so let's just do it this way. So if I run this, I haven't passed the argument board. So I have to pass the parameter board. I haven't passed it, so it's telling me I haven't passed it. So what is it doing? It's doing 147258.
You have to have that print with like the 2 like brackets.
Yeah, but right now it's printing 147258. We need to print 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So what are we doing wrong here?
Put column first, then row.
For every row, right? So I need to do. So let's define it this way. For every y, it's easier to think that way. So for every y, right, and x, I need to do x and y. That makes more sense to me actually. So I'm going x first, right, which is here, which is my inner loop, right? So inner loop is changing for every outer loop. Say outer loops y, for y0, I'm going to iterate inner loop is going to go 0, 1, 2. So that'll pick up these right values, right? So this should work. So let's do that. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the order that I want to print, right? Does that make sense? Did I confuse you guys? Right? So x, y. So we have to go column, then row. Okay, so if we go back to the other one, we had row, column. My board, I have to access the first column, right? The first iteration. So I have to say column, then row, because column is x. Okay, so this would do the same thing, right? I like to work with x and y's. It's just my preference because I know right away it's x is going horizontally and y is going vertically. Okay. So now what we need to do is that sorry, what did I do? I need to go y and x. Sorry. Okay, right, for each row, and for it, then for each one row we have to go for each column. For each row we have to go column. Okay, let's get that clear in our mind. It is very easy to get confused, but we can test it out, right? So it works. So now I need to somehow, I don't want to go to the next line for every in this for loop, right? For every row I don't want to go to the next line. So I would do, how do we do that? So I can just say end character is nothing. If end character is nothing, then it's just gonna it's gonna stay in that line basically. So it'll go 1 2 3 4 5 6 7 8 9. Okay, now, but I want to, for after I print the third one, which is this inner for loop, right, the first 3 characters, because I'm going for the first 3 columns. Once I'm done with it, I need to go to the next line. So how can I go to the next line? So after that for loop is done, I can just say simply do a print. This way, after every iteration of this for loop is completed, right? So I'm printing a new line for, basically I can read it this way, I'm printing a new line for each row, right? Now I have it that way. So now I just need to do some pipes in here, right? Because the question wanted these pipes in there, right? So now I can just do it very easily. So let's do that. So I can do, so I have to start with the pipe. I can just do a plus. So every time it starts with a pipe here, another pipe, and the end of it I need to put another pipe. So I can do a pipe here. This should work. Let's see if it works. What did I do? Oh, sorry. So what's it's complaining is that it's when I do a concatenation, this plus operator, I cannot concatenate a string with a number that I stored. So I need to change these to a number, string. Okay, because it's complaining that can only concatenate string, not an integer, to a string. So it has to, when you concatenate, it has to be a string with a string. So I'm changing all of these to a string. I can choose to work with strings or integers. In this case, I'm choosing to work with the strings, okay? Because obviously later on I need to set these values, the board position, to be X's and O's, and which are not numbers. So it's better for me to keep everything string. Okay, so now I have the board. Okay, so let's look at, so we need these characters as well at the top. That is easy. We'll just add those. So before we start doing this, we just do print 1 2 3 4 5 6 7, I think 7. So at the top and the bottom. Let's run this. Okay, so we have the board, right? So next thing is that we need to ask for a turn. Okay, so it's obviously it's going to start with X and then O. Okay, so let's so in our main method, we will define, main function will define turn. Okay, so I will call this turn. So turn will start with X, right? So now after I print the board, I can ask. So how do we ask? Input, what does we say? It's X's turn. So I will say it's turns turn, choose position. Okay,
Doesn't it have to be an integer input?
yes. So this will be the position. I'm going to get the position from the user, and I need to convert that to an integer. Okay, So I have the position. Let's just let's do this. Let's print this position, see if it's working out. Okay, so let's run this. So I have the turn. It has to say it's x's turn and get the position. Okay, let's see if it works. So it says, okay, x's turn, choose position. Say if I put 1, it gets me the 1. Okay, so I have done that. Okay, I got the position. Now using this position 1 has to correspond to, as per our go back to not this, it has to correspond to 0 0, right? So 1 has to correspond to 0 0, 2 has to correspond to 0 1, 3 has to correspond to 0 2. So one way of doing this is that the brute force method, where I could say, okay, so what we need is that from this position we need to get the x and y so we can go into the board, right? That's what we need to do, right? Because I need to somehow index into the board to change that value either to x or y, I mean x or 0, right? So we need to convert. So let's define a function that converts, so I would say get coordinate or something based on the position. So I'm going to pass in this position and it's going to give me x and y. So we'll return a tuple here. Okay, x and y. So we need to somehow find out how to resolve this x and y. Okay, so one way of doing this is that so if we go back to the diagram, so now you will kind of appreciate why these Python's these indexes starts with 0 instead of 1. Because when you're starting out, you're always wondering why didn't these guys start with 1, right? The element, first element. Why did they always use 0? It turned out they had a very good reason. It has to do with modulus and integer division. Okay, so if we take this row here, if I for a second if I see not as 1 2 3, but if I see it as, let me check a different color. Okay, if I see this as 0 1 2 3 4 5 6 7 and 8, okay, and if I deal with I'm dealing with 3 by 3, right? So if I take any number and if I do an integer division by 3, okay, so if I do position divided by 3, what would I get? If I divide 0 by 3, what would I get?
Wouldn't that position be 1?
Hmm?
Wouldn't that position be 1? Because they don't input 0, they input 1, 2, 3, 4, 5, 6.
Right. So I'm just saying that for now, let's imagine the position to be 0 1 2 3. Okay.
Okay.
So obviously they're going to put 1, but I can always say position, whatever their position, we're saying we're going to subtract 1 to it. Okay. So that's why these things are in, I'm just showing it in blue. So if we take this 0 1 2 3 4 5, if I divide by integer divide by 3, what would I get? For anything 0 1 and 2, I would get 0, right? So for position 0 1 and 2, I would get 0 as the value. And for 3 4 and 5, what would I get? Integer division. 1, right? And 1. 6 7 and 8, I would get 2. So this is starting to look like this is the indices, right? 0 1 2 and 0 1 2, right? So if I take any of these numbers and divide by 3, integer divide by 3, I'm getting, what am I getting? 0, 1, 2. What is that 0, 1, 2?
1, 2, and 3.
No, I mean, which one am I? Am I getting the columns, or am I getting the rows when I divide, integer divide? First of all, what is the division?
You get the rows.
I'm getting the rows, right?
Yeah.
You
Do you
get
see
your
that?
Y.
It's basically like I have 3 things in a row, so I'm dividing by 3, so I would know which row I would go to. It's simple mathematics, right? If I have 9 things and I divide by 3, I'm going to get 3, right? If I have 6 things, I'm going to get 2. So same thing here. So I'm dividing to get the indices. Okay. So if you think about it, I have 3 things in a row, so I have to divide by 3 to get the row, right? That's how you have to think of it. I have 3 things in a row, and I mean I have all these position incremented by 1. It goes from 1, 2, 3, 4, 6, 7, 8, 9. So if I divide by 3, I would be able to get which row it is. Okay. So this would work to get the row. So let's write that. So row is y. So y is equal to position, because position is going to be, as Belon said, it's going to be 1, 2, 3. So as per our calculation, we need to subtract 1. So we would have from 0 to 8, right? And having that value, if we divide by integer divide by 3, we would get the row. Does that make sense? Yeah. Now to get the column, how can we get that column? Let's go back. Let's see. So for 0, 1 and 2, we need to get, actually for 0, 3 and 6, we need to get 0, right? And for 1, 4, 7, we need to get 1, and 2, 5, 8, we need to get 2. So it's basically like this. So I have 3 elements in a row, right? 3 elements. Now if I want to find out which position it is in, I can say what is the remainder of that, right? If I say for any one of them, I can use the remainder. So this is so the remainder of what? So when I divide by 3, what is the remainder I'm getting? I'm getting, for this one, I'm getting, if I divide 0 by 3, I'm getting remainder of 0. If I divide 1 by 3, I'm getting a remainder of 1, right? So if I do this, modulo, which is the remainder, if I do that by 3, for 1, 4 and 7, what do I get? I'm sorry, first let's do 0, 3 and 6. If I divide by 3, I mean remainder for 0, 3 and 6, what would I get? Is there a remainder for 0? No, I'm getting 0. For 3, there's no remainder, I'm getting 0. If I divide by 3 for 6, I'm getting 0. So if we can see, for all the values in that column, I'm getting a remainder of 0. And for 1, 4, 7, what do I get? The remainder. I get 1, right? Do you see it? 1 divided by 3, you just have 1 remainder. 4 divided by 3, you have 1 3 in there and 1 remainder. For 7 divided by 3, you have 2 3's in there and 1 remainder. So I'm getting a 1. And obviously for the next one, 2, 5 and 8, if I take the modulo of that, I'll get 2, right? 2 for this and 2 for this. You guys see that? So this type of pattern will repeat many times in your programming career. This modulo, that's why this modulo operator is so important. Whenever you want to get like an index into something, you can always think of it as, you can think of using modulo. It's going to help you out. Okay, so division will give you the rows, right? That's simple to understand, because that we know from mathematics. If we just divide by something, that's going to tell me how many things are in it, right? How many of those things are in it. So if I'm at 6, if I divide by 3, I'm going to tell me, it's telling me I have 2 of those, which basically, so I'm just saying I'm in the second row, right? That's the way to visualize. And for modulo, it's basically, doesn't matter which row I'm in. If I divide by the number of elements in that column, and I take the remainder, which is the modulo, that will give me what position I am within that row. Does that make sense? Sort of. So let's do that. So y is obviously position -1 modulo 3. So now I can get the coordinates. Okay, so having the position, I can get the coordinates. So let's just print out the coordinates. And by the way, this I don't know if I taught you guys this. So get coordinate returns me a tuple, right? X, Y. And when I assign it to something, I can assign it to something called t, like tuple, or like whatever variable. This would be, let's say I print this one out. Let me just print this out. So this is giving me a tuple like this. Remember tuple? Right? So this actually, because when we do x comma y, it's actually returned as a tuple. The bracket is optional. I don't put the bracket because as per pip whatever, it's optional. It says remove redundant parentheses. Okay, so it comes out as tuple, but there is something in Python that's called what is it? Unboxing? No, tuple unpacking. Okay, so if we define a variable to match the number of elements in the tuple, like so, like I'm saying x and y, it will automatically unpack the tuple and assign the individual elements to my variables, like so, x, y. Did I teach you that? The unpacking, tuple unpacking? Oh, what happened to Krishna?
I think he misclicked.
Okay. So this is tuple unpacking, okay? So now I have the x and y right there. So if I print this, I will print xy. Okay, so it's just a handy way to quickly unpack. Otherwise I have to do t open bracket the square bracket 0 to get the first element in the tuple, and open bracket 1 to get the second element in the tuple, right? Remember the tuple, similar to list, how you access the values. Okay, so now we have the let's just run some other test. So let's put 2, that should give me 1 0, right? So let's do another test. If I put 9, it should give me 2 2, right? So 9 works.
You also put 10 though.
Well, 10 won't work, right? Because there's no position. So we're assuming for now that all the inputs that we're going to get are like good inputs, okay? I haven't taught you guys about how to handle these kind of exceptional cases when the input that you are expecting, like somebody inputs something else, okay? That we will talk about in the next or following coming up lessons, okay? For now, you can just assume the input that the user gives you is like within the range, okay? Similar to how we did for the dates calculation and all those things. Let's not worry about that input for now, okay? But I'll teach you guys how to handle those kind of situations. Okay, so we can see our get coordinate works. So what do we need to do next? We need, once we have the coordinate, we need to set it in that board, right? That value. So how do we set a value in the board? I can simply say, I have the x and y coordinate. I can say board x y, right, equal to turn, right? Let's see if that works. Let's just print the board. Okay, so I'm setting the board value and I'm going to print the board. I'm going to wait for it. Let's see if it works. So let's put 1. In fact, it is getting assigned, right? Let's choose a different one. 5. Okay, it is getting set, right? So I have a way to get the coordinate and assign a value to the board. Okay, now can I assign the board right away here? What if you imagine if I come back in the loop again, right? So let's do this. Let's take out that thing. Okay, so let's take out this print board. We have a print board here. So in a loop, we're going to print the board and take the position. So if I say x is turn 1, it's the set. Now if I set it again, it's just going to set that same position, right? Which is, so I need a way to switch the turns, right? So if x takes it, next turn is O's, right?
Yeah.
So let's do that. Actually, we'll come back to the position where we are overriding the position. We also need to check if that position is already taken by the player, previous player, or any player for that matter. Okay, so let's do that. So how can we switch the position turn?
You
So
could do like an if statement.
Yes.
So if the turn is equal to the x, then the turn equals to O, and then else turn equals to x.
Right. Right, because I'm going to keep doing it in a loop, right, every time, right? So let's test this. 2, O's position is selected, right? So we change the turn and we set the O in that next position. So now if I access position, if I say 2 here, it's going to override the O's position, right? So we need somehow way to check if that position was already taken. Okay, so let's write a method for that. Okay, anytime there's a work that needs to be done that seems like effort is involved, you always write it into a method. Okay, that's how you break up a problem into smaller chunks. Okay, so let's say is position taken, and I'm going to pass in, I don't need to pass the position as position. I can just pass xy because at this point I have the x and y, right? So how can I say if position is taken?
If position is, or if x, y, or if
So let's get the value in the board, right? We need to get the value because we need to compare the value in the board. So how do we do that? Board x, y, because we have the coordinates. So this will, so we, in addition to x and y, I need to pass the board too. Sorry. So we need the board too, right? Because board is a variable in here, right? This function.
Board.
Huh?
You forgot the last layer.
Yeah. So we need to pass the board and the coordinate. At this point, we have the coordinate. So here I'm saying get the value in the board. Now I just need to see if value is continue. What were you saying?
if value is not equal to x
Okay.
and not equal to o, or and value not equal to o.
Okay. So it is tempting in English. You would say, most people would say, oh, if value is not equal to x or not equal to y, or not equal to o, right? Instead of saying and, people would typically say as or. But would an or work in this case?
No, because if it's checks, it will just check if it's x, and then so x won't be x will be able to override o, but o won't be able to override x. That's what will happen.
Yeah. So it's like I'm only checking if not equal to x, and because it's not equal to x, and if I had an or, what would happen is the or won't even be executed because this is already a true. Remember, the or is if either any one of them are true, or would become true, right? The evaluation of or. So if not equal to x and I say it's true, then I never bother to check what if it was an x, or what if it was an o. Right? So what if it was what am I trying to say? I need to check both of them are not set, right? So it's hard to say it in English, but you guys get it? Why it's not an or? Vaishna, do you see it? Value should not be x and should not be o. Or another way of changing the same thing is I can say like this: not, okay, put the bracket, and I say this equal. Instead of not, I say equal. So I'm saying if not value is equal to x or value is equal to o. This is the same thing as saying the other one. Do you see that? So you can think of the bracket as being it's executed first. So this statement gets executed first, or this part. So value is equal to x or value is equal to o, and I'm saying it's not, then position is not taken. Okay, so that's another way of looking at it. Do you see that? It's kind of confusing, right?
The first one was easier to see.
First one is easier, right? So this is kind of like the English way, the way people say it, but they never, what they really meant is the not. Okay, so let's write it the other way. That is more easier, I think. So if any, so another mistake I've seen people make is that they're saying value not equal to x, and they forgot to put this statement, and they just say like this. That won't work. Okay, because the and has to operate on Boolean values. So this gives you a Boolean, and this gives you a Boolean. Okay, so then we check if both of them are true, then this statement would be true. So going back to it, so if value is not equal to x and value is not equal to 0, then I can say position not taken, right? Should I return true or false here?
True.
False. The position
False.
is.
We're saying position taken. So what should it return if position is already taken? It should return true if it is already taken. Right, Krishna? So here it should return false because it is not equal to x and not equal to o. That means it's one not one. It's one of the 1 or 2, 1 2 3 4 5. That means its position is not taken. Return false. Okay. Else return true. Had I set my method to be like is not position taken, then what you're saying would make sense. If I say is not, if I meant to say is not position taken, or if is position not taken, more English way of saying it. If position not taken, then I could say true here and false here, right? Because I'm asking is position not taken, but usually you say position taken, so I would work with the positive cases, okay? Because what I want to do is if the position is taken, so I cannot just simply write it here, so I have to see if I should only do if position taken pass the xy, if not taken, right? If it's not already taken, then only I should set the board. So maybe we should actually change it back. Right? I don't like this not in here. So let's take this out and change this method name to be not taken and say position not taken, and then change this around true and false. Right? So we only want to assign the value if position is not taken. Okay, so you have to be very careful about these Boolean values, how you determine. Okay, you will make these mistakes time and time again. So if position, so what if the player, so let's run this.
You need the board
Hmm?
for the if the is
Oh, sorry.
not taken.
Why is it still working? Oh, that's another thing. That's another Python thing. If you don't pass in enough argument, it'll still try to do something and it'll fail later. Okay. So if position not taken, then do this. Okay. So if the position is already taken, we need to warn the user, right? So let's do that. So it says somewhere here, if it's x's turn, position 1 already taken, right? So let's print that. So where do we want to say it? We want to say it here, right?
You have to put the turns changing with the if turn equals to x and turn equals to 0 underneath the first if statement with the position not taken.
Yeah, but let's do this part and then come back to that. Okay, so if, so we have to say where is it, position 1, so we have to say position, I'm going to convert because I have it as integer, I need to convert it back to a string. Okay, this is str function will convert it back to a string because I need to concatenate string with a string. Position 1 already taken. Okay, so this will tell me if it's already taken, but there's no guarantee that the next position that the person will take. So we need, if this is if this is true, right, we need to let the person take the turn again, right? So obviously we need to keep taking that turn from the user till he has given us the valid position. Okay, so let's turn this into a while loop because we need to ask that good position. Okay, you guys see that? Let's do that. Okay, so how can we do that? We need a while loop, right? So we can say while So how can we do this? Let's see. So let's write a method. Let's write all of these things in a method, right? Asking for the position. Ask position, and we have to pass. Let me think.
The board.
Yeah. So we need to while position not taken, or while position not taken. Okay, let's just do this without the method, and then let's come back to it. Refactor. Okay. So we have to ask all of this stuff. Okay. So let's do that. So I'll create a variable temporarily that says valid position. I will assume that it's not a valid position to begin with. Okay. And I will say while valid position, while it's not a valid position, because I need to repeat until it's a valid position. While not position, I will ask this. Okay, so it's going to say it's not, initially it will be not a valid position, and I'll say I'll ask for the position, get the coordinate, and if the position is taken, I will set it. Okay, and once I set the board, I also need to say, so if it is a valid position, I would say valid position equal to true here to prevent the loop from happening again. Okay, so initially I set it to assume it's a false position, and I take the position and I see if it is a valid position, then I set it to true. So I don't need to repeat again. If it is not, I will say position already taken, and then I'll ask I'll ask for the position. Okay, does that make sense? You see how
Yeah.
I created a, so let's see if it works. Okay, so once this is done, position is taken, this part is still okay, right? I can still keep this one, right? Because I still need to, why is this giving me blank? Okay, so let's run this. X's turn, put 1. Now it's O's turn. If I put 1 here, it'll say position Y already taken, and it's still going to ask me O's turn. If I put 1 again, already taken. If I put 2, it'll take the second 2 position, and it switches the turn. I still need to switch the turn, right? Does this make sense? This works, right? Okay, so let's keep this. I don't think we need to create a method. Let's keep this. Okay, because we need to get a right position. Okay, so now before I switch here, what do I need to do? What should I need to do? Like
You
basically,
need to see if they won.
yes, player 1, right? Because if you think about a game, after somebody takes the turn, we need to check if the player won, right? Because computer needs to check for every turn. In fact, you are actually doing that in your mind every time somebody takes a position, right? So let's define a method. Has player won. I'm going to say that. Okay, I'm going to take the board, obviously, and the player. Okay, player could be X or O. Okay, and this method needs to return me true or false. Okay, so how can I do this? Has player won. Going back to the board, as per the rules of the game, I just need to check if the position is the same. The player is the position, right? So this player is sorry, the player is the X or O, right? So I need to see if the player is in all the rows, right? Either in any of So I need to check all the rows to see if the player is the same player in all the columns for each row. And I also need to do it for each column. I need to see if the player is the same in all the rows and also the diagonals, right? So let's do first the rows. Okay, so we need to do it for each row. So let's, obviously it's an iteration, so we will say for row in range 3. Okay, so for each row I need to calculate whether all the columns have the same, right? So I can say for column, what can I say? I can check if board at column row equal to so how can I say, if it is equal to player, so basically I'm going row by row and I'm checking one by one. If it is not equal to the player, then we know for sure he has it has to, all of them has to be true, right? All of them has to be player. Any ideas?
If board call row is equal to, wait, what did I write?
If it's equal to the player,
Okay, so we need to check all three values, right?
Oh, yeah, okay. I know.
So
Wait, are we checking the rows first?
yeah, we're going by rows.
So then you have to check if call, or no, call 0 is equal to column 1 equal to column 2.
Yeah, so we don't really need this guy, right?
Yeah, or you could use row, yeah. But you don't need it. You only need one for loop.
So we will do this. Column equal to player, and so here would be row would be okay, but column is going to change, right? Column is going to be 0, 1 and 2, right? And so if all the three columns are same player in that row, right, then I can just return true, right? So I'm going by row for each row. I'm going for 3 rows, right? That's this thing. First row, I check if all the 3 columns in that row are player, then I return true. Okay, so this will check all the rows. Now we need to check for all the columns. So I'm going to say column in range 3. So now instead of this, it will be column. I need to check 0. Yeah, we need more time. We have time. Right? Is this correct? So for the same column, right, I need to check row 0, row 1 and row 2, row 0, row 1 and row 2 are same player. If it is, then I say true. Okay, so that's the rows and the columns. What about the diagonals? I can do something like this, right? If so, diagonal is 0 0 1 1 and 2 2. If that is, then I can say true. Even if that doesn't work, that's this diagonal, like this way, right? 0 0 1 1 and 2 2. This diagonal, how would I write the other diagonal? If
0 2 1 1 2 0.
0 2
1 1.
is it
And
0
then
2? How are we? Oh, this guy here.
0, 2,
yeah, 0 2
1,
1 1 and then 2 0.
2 0.
Oh, you're going from here. 0 2 1 1
2 0.
2 0.
Well,
I was going this way.
oh,
So
okay.
I would say 2 0 because we went this way. 0 0 1 1 and 2 2. I'm gonna go this way. Okay, so that's 2 0. 2 0 and then 1 1 is still okay, and this guy is 0 2, right?
But we could put both those diagonals in one if function, right?
How?
What I did was if 0 0 if board 0 0 is equal to board 1 1 equal to board 2 2 equal to player, or and then I did the other one.
Yeah,
And then you could just check if the middle one is, and then you can just and then you can do that in one function. In my function, I did differently. I returned 2 1 as well.
2 1.
I returned a number like 1, 2, or 3
Oh,
for
okay.
player 1, player 2, and tie.
Okay, but this is basically this is one diagonal, right? These are all the diagonals. These are all the rows. These are all the columns. And then if none of them are true, then we just need to return false. This kind of flows our thinking, right? The law. This would work, no? Yes?
Yeah, it would work.
It would work. All right. So we have to check if the player has won. Okay. So after the position is taken, we have to see if what do we call our function? Has player won. Has player won takes the board and the turn. Okay. If it is, what do we say here? We have to ask okay, I didn't mention that. So we have to ask them, what do we say? Oh, program should prompt the user whether they want to play a game come to an end, win or draw. Okay, so has player won. Also we need to check if it's a draw too, right? So we need a method for that too. So let's just do this has player won first. Okay, so if the player has won, then we need to ask the user if they want to continue. Okay, otherwise we keep switching the turns. Okay, so let's move this turn up here. Okay, so if player has 1, oh, we don't want to move the turn, sorry.
If you move the turn, then
Yeah.
it will make it so that the second player would win.
Yeah. Well, we're not doing it properly, so we only need to turn here. Okay, so has player 1. He has 1. Let me think. Let's ask the user, continue or not, play again. I'm going to create a variable play again. So actually this true, let's change this to be not true but rather another boolean or a thing. Okay, let's call this play equal to true. Okay, so while play, we'll say this is going to continue, and we're going to ask again here. Okay, play again, and we'll ask the user, oh, we have to say player 1 first. Oh, how do we say this?
You have to do turn plus, and then it's like, then you write another string.
Just say turn 1. Okay, so turn 1, right? As player 1 turn. Okay, that's it. And then even also we need them. Okay, let's come back to that. So then again we're going to ask player, do you want to play again? Okay, do you want to play again? Let's say, what did I say? 0 to continue. 0 to continue.
You said 1 to
Want to
continue,
continue.
0 to exit.
1 to continue.
Does this thing have to be an integer? Like, you know, it says input thing.
Yeah, it has to be an integer.
Int.
Okay, so we'll ask this. So we have the play again. Then we have to check here if play again equal to 1. Actually we just need to check if it is 0, then we have to say play equal to false, right? Play is our main loop. So if they say I don't want to play again 0, then I just set it to false, otherwise I continue, right? So at the same time I need to change the from previous player to, let's say the previous player was X, I need to change the player to be O, right? So I need to do that. So let's keep another one call. You confused? You get a question?
No.
Okay, so we need to keep another variable as well because X started this time, right? So next time around we should have O started. So and this turn is within the game, not between games, right? So we need another variable to separate that. So this, let's say this is starting player. Okay, starting player will be X. So we need to do the same thing here. If they say play again, so if they want to play again, I have to say if starting player currently is X, then I have to say starting player equal to O. Else starting player equal to X. Okay, So if they wish to continue, I'm going to change the starting player.
But then you have to change turn to that starting player.
Yeah, so we have to change the turn to that starting player too. So how can we do this? Because we're changing the turn between every. So we only need to change the turn. Okay, so what we need to do is has player 1. Otherwise, we need to do this turn. What am I doing? The tabs are very important. So here, if the player has not won, we are changing the turns because this is within the same game, right? Now here for the other one, when we start a new game, we set the starting player to be 0. Now in this case, we also need to set the turn to be O as well. Turn to be the starting player. Right? This way we are making sure that the next loop, right? Players that the turn starts from the starting player.
Can't you tab that indent it the other way and remove it from both of them and just put it outside the else statement? Because both of them are turn equal to starting player.
Sorry, I'm not following.
So the part where it says turn equal to starting player,
yeah,
you could remove that inside the if and else statements and then put it outside for both of them.
Oh yeah, sure, we can do that. That's a good point. So we just do it here, right?
Yeah,
we can say this. So turn is now new turn, starting players. Okay, so let's see if this is gonna work. So this will only work if the player has won. We asked this. We also need to check. Okay, let's see if it works. Okay, this one. So let's make X win. 1, 2 for O, 5 for X, 3 for O, 9 for X. Okay, X1, do you want to play again? Okay, so if I say 0 to 1 to continue, now it should say it's O's turn. Okay, so it's saying asking for O's turn, but it never reinitialized the board. Right? Still the old board is showing. So we need a method to reinitialize the board, to bring it back to the old position. Right? So let's define a method for that. So I say initialize board. I'm going to take the board. So here I just need to go for X in range. So one thing, when you get this board, I cannot simply say that board should be equal to, well, since I'm taking, okay, I want to show you the difference. So can I say like this, board is equal to this in here, and I call this. So if somebody player has won, I can say at somewhere here, reinitialize board, and I pass the board. Can I do this in here like this, board equal to this?
no, because it's inside.
Yeah, so why it's inside is, let's look at this. This is some other important concept. So so I had a board that is pointing to some memory space, some list, right? Now somewhere in the function outside I have reinitialize, and I pass this board. right? So what happens is that when I pass this board into this function, remember this board is a label, right? It's pointing to a memory space, right? When I pass it as to this board, what will happen is this board will simply point to that memory space. Okay, so that's how it works. So this board will just point to that board, because I'm passing board as board. I could have named this not to be board, I could have named it B or something. Then you can see the difference. So the B will point to this. Okay, so within that, inside my method, if I say B equal to some new one, what will happen is this guy, instead of pointing there, he will just simply point here. But the outside guy board is still pointing to that one. So I never end up changing the outside board. So that's why.
If you make why do you need to make a function if you could just write outside without in the function we were in before, board equal to 147?
Yeah.
That's
So
that.
you could have done it. So within the while loop, you could have just simply did board equal to this, right? That's kind of reinitializing. But I wanted to show you the difference. So if you pass something outside an array or a list, right? And if you try to do like this, you might think that the board will get reassigned, but in fact it won't be. Okay, because you're just only doing it for this guy only. You're not changing the outside. If you want to change the outside, what you have to do is you have to go inside. So right now B is board is pointing, this board is pointing to that one, right? So but if I say something like board, and if I try to access it and set it a value something, let's say 1 or whatever, right? If I do this, this will actually, it actually goes into that one and changes that value. This will work, but changing the board itself to some new one won't work, because that you're only just pointing this internal board to a new memory space. Okay, which is you're just doing like this. So this is an important concept to remember. So within the function, if you try to assign something, it's just going to assign it to only this guy. It's not going to assign it to the outside variable. Okay, something to keep in mind. But if you want to make a change to the outside one, you have to go inside, like access it like like this, and assign a value. Then that outside one will get changed. Does that make sense? So when you're working with this list, you have to keep in mind, if you want to change the outside list, you have to go into and change the element inside the list. You can't just assign it like this. I can just put it something here and hoping that the outside board will get this value. Okay, so let's go back. So if I want to reinitialize, I know that you can just simply in here you can just do this board equal to whatever, right? This guy. This will work because you're still within that same method, and you can do this. This will reinitialize the board. Okay, but I just don't want to repeat the same thing again. I have two places the same thing, so I would rather have this thing called reinitialize board. Okay, or I will call this initialize board. Okay, and I can just simply return this thing from here. This is one way to do it. Return. So if I return here, I don't have to have a board like this here. I can just say board equal to initialize board. I don't need to take anything. And in here I can just say board equal to initialize board. Or, well, I can call this new board or something. That makes more sense. Board equal to new board, and then board equal to new board. So in this case, I don't care about the old values. I'm just going to override this board with whatever is returned by that new board function. That could also work. That makes it more concise, right? This one I'm just returning the whole thing, and then that gets assigned to the board. And same here, that board I'm just assigning a new board. Yeah, that makes sense, right? Okay, let's see. So let's try to make x win. 1, O is 2, 5 for x, 3 for O, and 9 for x. Okay, x1. Do you want to play again? 1. Board gets initialized, and now it's O's turn, right? So if I say 1, O gets assigned. Let's try to make O win this time. 5.
How come on my code when I typed in x1 0 2 and then the x is 3, it becomes as x1.
I don't know. You must have made a mistake somewhere. Were you just trying to copy what I was writing?
Yeah, and then it just wrote 1 2 and 3 like this.
Okay, you must have made some mistake somewhere. Okay, let's just finish this one. So x's turn is 3 here, and 9 for O, so you should say O1. Okay, do you want to play again? Or if I say 0, it exits. Okay, so we have the winning done, but we also need to check if it is so in the case when nobody wins, also we need to change the board around. Okay, so where are we switching that? So we need to ask,
How did the x win above yours in yours? It says 0xx 0.
where?
Like when you on your console, it says on the last one before you won, it says 0xx. It's at the very bottom. It says 0xx 406. There's no winner in there.
It doesn't print
We
the.
didn't print the last round
Oh.
after.
It doesn't print the last one. Okay, so we need to, has player won, we need to print the board, right? Somebody won. Sorry, what? So if I say position 9, oh, okay, take the position. I didn't set it. Okay, okay. So what can we do here? Do you want to play again? So before this, we need to print this.
You need to print it before the.
Oh yeah, sorry. Okay, that will fix that. Yeah, x1, right? So what do we need to do now? We need to check if the player has is a draw, right? So how can we, let's create a method for that. Is draw, pass in the board again. So one thing I can do is if it's a board, if it's a draw, so up here I'm checking has player won, right? If the player has not won, then only I need to check if it's a draw, right? So assuming that nobody won, when I get this board, right? How can I check if it's a draw?
If draw.
I can check,
Use a range.
yeah, so I can check all the values and see if all the values are either X or O, then I know that it's a draw, right? Because I've already checked if it's somebody won, and if nobody has won, and I check if it's a draw, right? If all the values are X's and O's, then nobody has won, it's a draw. Okay, so I can say for 3, so I can say if board at xy not equal to x and not equal to O, return false, right? That means there's a number there, otherwise return true. This would work, no?
No, wouldn't that return false for every single one that's X? If it'll return multiple times, or it will just exit after.
Yeah, as soon as I find some position that is not X
Oh yeah,
and not
okay.
O, I'm saying it's not a draw. I still have a,
Oh, yeah.
basically I still have a position still leftovers to play, right?
Okay.
I'm just
That
making,
makes
otherwise I say it's a draw. So I have the draw. So I'm saying if has player 1, else I can say here has player 1 LF draw is draw, else it's not a draw and they need to play. So if it is a draw also, I need to do all of this stuff, right? So let's I'm just going to create another variable here saying what is it? What do I need to do here? Okay, I'm going to say prompt to play again. Okay, so I'm just going to say prompt to play again. Oh, actually it doesn't work that way. Player 1, only this part here. Would this work? So what I've done is, if the player 1, I just say print the board and say player 1, right? If it's a draw, actually I need to print the board again, similar to that. right? So if it is not a, if nobody won and it's not a draw, I just change the turn and I move on, and I created another one variable, say prompt to play again, and that gets only set if somebody won or a draw. Then if I see, if I need to prompt again, I say, I do the, I ask them, do you want to play again? And if they say yes, I say if they say no, I say play false, and I exits, the whole loop exits. Otherwise I set the starting player to the new, like the the opposite player, and then I set the turn to be the starting player, and then I reinitialize the board, right? I think that should do it. No, what do you think? You guys see what?
If it's a draw,
Huh?
if it's a draw and you say,
Oh yeah.
I'll
So
draw.
I have to say, okay, I have to say after I say this thing, print it is a draw. Is that what I said? It is a draw. Okay. Let's test this. So let's make somebody win. 1, 2, 5, 6, 7, 8, 9. So x1. Do you want to play again? 1. Okay, it's O's turn. Let's choose this time 5. And x is 2. O is 1. And x is say 3. O is 9. O wins. Okay, do you want to play again? Yes. X's turn. Okay, let's make x win this time. Let's make it a draw this time. X 1 for O, and x is 9. Let's say O is 3. X is 2. And O is 4. X is 6. And O is 7. And O is 8. X is 7. Okay, it is a draw, right? Do you want to play again? So this time, who won? Who went last time first?
It was X and then it was the O. So if we do it one more time, then it'll be X.
So do you want to play again? It was X's turn. So this time it should be O's turn, right? If I want to play again. Is that correct?
Yeah.
Okay, so if I want to continue, it's O's turn. Alright, so that's it. It works. I think that's it. No? You guys want to test any conditions? That was a long class today. But I hope it's worth it. Did we learn anything new? I think we learned a lot, right? So any questions on how we did this? Should be crystal clear. Anyways, I think there are some improvements that we can do, but I just wanted you guys to get the feeling of how do we like solve a big problem, right? Just have to start from the very basic and just start adjusting your program as it evolves. Okay, so like, do you guys see when I would use variables? Like sometimes you don't know when do you need to create a variable, right? Whenever you need to somehow create a state, you create a variable. Yeah. Do you guys see when you need to create the variables? All right. Okay, another problem that we face is that whenever our program gets bigger and bigger, and sometimes the program just doesn't work, right? You don't know what went wrong in your program. Like Krishna, you're typing and you're like, I don't know what went wrong, right? So I think in next class I will teach you something called unit testing, uh, where you write a program to test your program, so you will make less mistakes. The program itself will try to validate your program. Okay, and also we'll try to do more practice on the list of list before our next assignment. I haven't decided what to give you guys. So are you guys finding this more, are you guys getting a feel for this programming? Like, what is challenging? I know it's challenging beginning because a lot of things go wrong, right? Because you're beginning out and it's kind of frustrating. But the more programs that you write, you're going to get better at it. So whenever you see an error, you know exactly what's the problem because you have seen those before. So you have to get those, you have to see those problems in order to get better. Okay, so don't get discouraged when you see all these problems. That you're learning. Okay. Okay. So that's it for today. Okay. This is a long class. All right. Bye.
Bye.